You know, looking up at the moon, I bet everyone's wondered at some point, where did that thing even come from?
It's a question that's really captivated us for, well, basically as long as humans have been around.
Right, even before we really knew what to make of it. Like before telescopes and all that.
Yeah, like we told myths and stories about it, trying to make sense of it.
Exactly. And the science is just as interesting, I think, because it's not like there's just been one idea about it.
Oh, not at all. It's like there's been all these different theories over time trying to explain how the moon got there.
A whole bunch of lunar origin stories?
Yeah, there you go.
So, like, one of the early ones, this one's called the fission hypothesis. And it basically says that the early Earth spinning super fast, like way faster than it does now, spun so fast that a piece of it, like, broke off.
It's a wild thought, isn't it?
I know, like, almost too wild to believe.
It is interesting, though, where it came from.
What do you mean?
Well, it was actually George Darwin, Charles Darwin's son, who proposed it.
Oh, wow. So the guy who figures out evolution, his son is trying to figure out the moon?
Something like that. Like father, like son, I guess.
Huh. Okay, so we've got the Earth spinning so fast it throws off the moon. That's one. Then there's the capture theory, right? Like the moon was just out there doing its own thing, and Earth's gravity was like, nope, you're mine now.
Yeah. Imagine that, just wandering through space and then whoosh, caught.
No more cosmic road trip for you.
Exactly.
And then, of course, there's the idea that they formed together, the Earth and the moon, like from the same cloud of stuff way back when.
Kind of like cosmic siblings, you know?
Right. Born at the same time from the same, what is it, primordial soup of space stuff?
Yeah, something like that. Yeah. But, you know, like some siblings, they don't always get along or even really look that much alike.
Right. And that's kind of a problem for that theory, huh?
Yeah. There's some pretty big differences between the Earth and the Moon that are kind of hard to explain if they form together.
Okay, so we've got these early ideas trying to figure out the moon. But then there's this other one that really kind of changed everything we thought about the early solar system.
Oh yeah, the giant impact hypothesis. This is the one that's become the most popular.
The reigning champ, huh?
Pretty much.
So what's the big idea?
Well, it basically says that way back when the solar system was still young and crazy, a protoplanet, they think about the size of Mars, smashed into the Earth.
Whoa, back up. A planet the size of Mars. That's huge.
Yeah, it wasn't pretty. They even gave this protoplanet a name, Theia.
Theia, huh? So what happened? Did it, like, sideswipe us or something?
More like a head-on collision, I'm afraid. We're talking massive, unimaginable impact here.
Okay, so not good. But the moon came out of it, so how does that work?
Well, when Theia hit the Earth, it wasn't just a fender bender, right? This impact was so powerful, it melted and vaporized huge chunks of both planets.
Ouch, that's gotta hurt.
Yeah, not a good day for either of them. So you've got all this molten rock and dust just blasted out into space, creating this huge cloud of debris.
Like a cosmic explosion.
Exactly. But here's the thing, this debris, it didn't just fly off into the void. Gravity did its thing.
So what, it all got pulled back together?
Pretty much. But not just back to Earth. Well, some of it, of course. This cloud of Earth and Theia bits, it starts to clump together, kind of like how a snowball grows as you roll it.
Wait, so the moon is just a big cosmic snowball?
Well, not exactly a snowball, more like a giant ball of molten rock and dust. But yeah, over a long time, that debris cloud coalesced, cooled down, and eventually, what do you know, it became our moon.
That's wild. It really makes you appreciate just how powerful those forces in space are, huh?
It really does. But, you know, the best part is, this theory isn't just some wild idea. There's actually evidence to back it up.
Okay, so what kind of evidence are we talking about? How do we know this crazy event actually happened billions of years ago?
Remember the Apollo missions? When we went to the moon, they brought back a bunch of moon rocks?
Yeah, those were huge.
They were. And those rocks were like finding a treasure trove of information.
What do you mean?
Well, we analyzed those moon rocks, figured out what they're made of, and guess what?
What?
The composition of those rocks is surprisingly similar to the Earth's mantle.
The mantle, that's like the layer below the Earth's crust, right?
Yeah. So it's like finding two puzzle pieces that fit perfectly together, even though they were found miles apart.
So the moon is made of, like, Earth stuff.
Or at least very similar stuff, which really points to a shared history, you know, like maybe they were once part of the same bigger thing.
That's pretty convincing. But scientists like to be sure, right? So what else is there? So besides the moon rocks, are there other clues that point to this giant impact?
Oh yeah, tons. You know how scientists love to recreate things?
You mean like in a lab?
Well, kind of, but in this case, they use computers. They build these incredibly detailed simulations to see what would happen if a Mars-sized object smashed into the Earth.
Like a cosmic crash test.
Exactly. They plug in everything we know about physics, the masses of the Earth and Theia, the estimated speed of the impact, and they let it run. And guess what?
It explodes.
Well, yeah, kind of, virtually at least. But the cool part is, a lot of these simulations, they actually end up forming a system that looks a lot like ours. A planet with a moon, the right size, the right orbit, even the right kind of composition.
So like a proof of concept kind of thing.
Exactly. It's like the universe is saying, yep, this could totally work.
That's pretty cool. Anything else?
Oh yeah. There's also how the moon orbits the Earth. The angular momentum of the system is a bit of a giveaway.
Hold on, angular momentum? That sounds like something out of physics class.
It is, but it's not too complicated. Imagine a spinning ice skater. When they pull their arms in, they spin faster, right?
Yeah, I've seen that.
That's angular momentum. The Earth-Moon system, it has a lot of it. Way more than you'd expect if they just formed together calmly. But a giant impact, that would totally explain it. All that energy and spin transferred from Theia to the Earth and the Moon.
So even the way the moon moves tells us something about its past. That's amazing. But didn't we say there were other theories too? Like, what about the whole Earth spinning so fast it throws off a chunk of itself?
The fission theory. It's a fun idea, but the evidence just isn't there. For one thing, there's no sign on Earth that something that big ever ripped off of it. And physically, it's tough to make it work. Earth would have to be spinning crazy fast, like way, way faster than it does now.
Okay, so no super spinning Earth then. What about capture? Like the Earth's gravity just reeling in the moon as it passed by?
Capture? Possible, but not very likely when we're talking about something the size of the moon. Think about it. The moon would have to come close enough to Earth to get caught by its gravity, but not so close that it crashes. Then it would need to be slowed down somehow to stay in orbit, rather than just zipping off in another direction.
Sounds like a lot of things have to go right at exactly the right time.
Yeah, it's a long shot. Much less likely than a giant impact, that's for sure.
Okay, what about that last one, the co-formation idea? Things seem too crazy.
It's true. It seems kind of intuitive that they just form next to each other like buddies. But here's the thing. If they were born from the same cloud of stuff, why aren't they more alike in what they're made of? Especially their cores. The moon's core is tiny compared to the Earth's. That doesn't really fit with the co-formation scenario.
Right, makes sense. So back to the big dramatic impact then. Case closed.
Well, mostly. But that's the thing about science, isn't it? Always more questions. The giant impact hypothesis explains a lot, but it doesn't explain everything. Like, what was Theia actually made of? We haven't found any pieces of it yet.
It's like a ghost planet, smashing into the Earth and vanishing.
Kind of, yeah. But figuring out more about Theia, that could tell us even more about Earth, even about, well, us. Like, did it have water? Did that water end up on Earth because of the impact? Did it maybe even bring some of the building blocks of life? Lots of stuff we don't know for sure.
Wow, so this one event, billions of years ago, could have made Earth the planet it is today. Pretty incredible when you think about it.
Absolutely. And it makes you wonder, are there other Theias out there? Could something like that happen again?
Now that's a scary thought.
It is. But don't worry, astronomers are always looking out for anything that could pose a threat to us.
That's good to know. Well, this has been fascinating. From a simple question, where did the moon come from, to like giant impacts, the early solar system, even the possibility of life itself. Who knew?
It really shows how much there is to discover, right?
Yeah.
And how much we're still learning.
Exactly. Well, next time we look up at the moon, it'll be hard not to think about all of this, huh? A giant cosmic crash, the birth of a satellite, and maybe even the seeds of life on Earth.
All thanks to science, piecing together this incredible story.
Absolutely. Thanks so much for taking this deep dive with us. It's been an incredible journey back in time. Who knows what mysteries we'll uncover next as we keep exploring the universe.